Okay, Algebra 1. I am on page 636. We're going to do example 2 in a second, but I actually want to start with guided practice 2B. Okay, guided practice 2B. And that's what you can see here on my page. So again, we're going to add and subtract radicals today. Okay, just like we did yesterday. But this time, you'll notice that these radicals aren't the same. Okay, so if you remember from yesterday's video, we can only add or subtract radicals when they are the same. So what we're going to do first is we are going to start by simplifying. We're going to look for a perfect square. Right? We've done this before. A perfect square that goes into 12 and 48, trying to get both of them as simplified as possible. So let's start with this 12 here. I know a 4 goes in there, so I can rewrite this as 4 times radical 4 times radical 3, right? 4 times 3 is 12, and I chose this because 4 is perfect, okay? And we know that the square root of 4 is, that's timesing right there. We know that the square root of 4 is 2, so I have 4 times 2 times radical 3. And we know that 4 times 2 is obviously 8. So the simplified version of 4 radical 12 is 8 radical 3. As we have a minus sign, right? I'm going to just drop that minus sign all the way down here. Okay. Let's do the same thing with the 48. Let's simplify. Let's look for a perfect square that goes in there. I think it's 16. 16 times 3 gives me 48. So I'm going to write this as 6, and it's going to come down. I'm going to say 16. And we said 3, right? 16 times 3 is 48. Cool. We know that the square root of 16 is 4. So now I have 6 times 4 times radical 3. 6 times 4 is 24. Still got that radical 3 back there. And now, if you look, once we've simplified, now the inside numbers are the same. So we can just go ahead and combine them. What is 8 minus 24? 8 minus 24 is a negative 16. And remember, when we add and subtract, the inside number does not change. So our answer for 2B should be negative 16 radical 3. Okay, I'm going to switch pages here because I want to try example 2 with you guys, because this one has, I think, 3 terms. I've got a 2. This is example 2 here, still on 636. So I got 2 radical 18 plus, what is this, 2 radical 32 plus radical 72. Okay, and I will keep my list of perfect squares over here so you guys can see that as well. Alright, so we're looking for perfect squares, remember, that go into 18, 32, and 72, right? So we can reduce and simplify all of these. So I think 9 goes into 18, so I will rewrite this as 2 radical 9 radical 2, right? Everything's timesing here, and we know that the square root of 9 is 3. So I got 2 times 3 times radical 2. 2 times 3 is, I'm off the screen there, sorry. The 3 came from the square root of 9. 2 times 3 is 6, right? So I got 6 radical 2. There's a plus sign there. Let's come back to the top. I know 16 can go into 32. 16 times 2. So I'm going to make this 2, and then we're going to say radical 16 times radical 2. Right? Everything's timesing. And we know that square root of 16 is 4. So now I have 2 times 4 times radical 2. And 2 times 4 is obviously 8. So I have 8 radical 2. Last one. There's a lot of perfect squares. Oh, not a lot, but there's multiple perfect squares that go into 72. But the biggest one, remember, if you want to find the biggest one, just start going backwards. 72 divided by 64 is a decimal. 72 divided by 49 is a decimal. But 72 divided by 36 should be 2. So this number outside is just a 1, which we don't need. So I'm going to break radical 72 into 36 times radical 2. 36 times 2 is 72. And we know that the square root of plus sign here, I'm going to bring him down so we don't forget. Square root of 36 is 6, and this is radical 2. Now, you can see that I got 3 radical 2's here. They are all the same, so we can just add and subtract. We're only going to do the outside numbers. 6 plus 8 plus 6, I believe, is 20. So we got 20. Remember, even though there's 3 of them, we're just going to leave it as radical 2, right? The inside does not change when we add or subtract. So our answer here is 20 radical 2. Okay, guys, I'm going to try one more with you. This is the last one for the day. Woo! Or last one for the week, I guess, until I give you that quiz. But keep our perfect square list there. I would like to try, let's go over to 637 now, and let's look at number 7. And you'll see why I chose number 7. This one is square root of 8 plus the square root of 12 plus the square root of 18. All right, so we got 3 terms again. Perfect square for 8 is 4. This is square root of 4 times square root of 2, plus sign. We know that square root of 4 is 2. So we're going to leave this as 2 square root of 2. Perfect square for 12 is also 4, right? 4 times 3, so I'm going to make this radical 4 times radical 3, gave us 12. We know the square root of 4 is, plus sign there, square root of 4 is 2, and there's my radical 3 with it. 18, perfect square that goes in there is 9. I'm going to break this into square root of 9 times square root of 2. And we know that square root of 9 is, another plus, square root of 9 is 3 square root of 2. Okay, so I chose this problem because now, if you notice, we've simplified everything, but we still have different radicals, right? We have a square root of 2 and a square root of 3. Those are different, right? So we can only combine the ones that are the same. So I have a 2 plus a 3. 2 plus 3 is 5. So it's 5 radical 2, right? Remember, the inside does not change when we add. And since this is a radical 3, we're just going to write it plus 2 radical 3. Remember, we talked yesterday how the radical kind of operates like a variable. So if this was like 5x and this was 2y, we couldn't say 5x plus 2y. We would just leave it as a binomial. We would say 5x plus 2y. So we can't actually combine these because they are different. So our answer is this binomial, and it looks like that. Okay. All right, guys. I do want you to try a couple of problems here. Looks like it's also on page 637. Okay. 637. I want you to try numbers 5, 6, and 8. All right, 5, 6, and 8 on 637. Good luck.